Okay, so last time we discussed about probability briefly, and before that we understand what is permutation, what is combination, how to use permutation combination, what's the use of factorial, and then what's the difference between using a factorial and NPR formula. Okay, so hope you remember that. So let's move on to the next topic. So before that, I'll just quickly go through the Venn diagram thing, which we briefly discussed last time. So if you understand set theory from your previous classes, let's say, it's very easy to understand this probability as well. Yeah, this will be available on YouTube, Frank. Okay. Okay, so in the case of Venn diagram, the rectangle represents the universal set. Okay, and then you have sets which is represented by a circle or a sphere. Let's say this is set A, this is set B. So what we define as this region here is called the intersection, isn't it? So this is, oops. So this represent here intersection, which means A intersection B. Intersection means common. And this part here represent number of elements in A minus A intersection B. And this part here represents number of elements in B minus A intersection B. Okay, so I'm just talking about the blank part there. So if I add n of A minus n of A intersection B, which is, let's call this number 1 region, number 2 region, and number 3 region, let's say. So in the first region, you have number of elements in A minus n of A intersection B, plus in the middle, in the second region, you have A intersection B, and in the third region, you have n of B minus n of A intersection B, isn't it? And this should be equals to n of A union B. A union B means altogether. So this is the equation you can write down based on the regions, isn't it? And you can see that you can cancel this, and what you left with is n of A, n of B minus n of A intersection B equals to n of A union B. Okay, n means number of elements. Generally we use hashtag as well, if you remember. Hashtag A, hashtag B minus hashtag A intersection B. Hashtag means it represents the number of elements, and hashtag A union B. Okay, but I prefer using n, it's simple. So I'll just remove this for the time being. So if I divide now each term by the total number of elements, okay, so total number of element is, let's say, capital N, capital N, capital N, capital N. So mathematically I can divide everything by capital N. So what will happen then? This will represent the probability, because probability means number of outcomes over total outcomes, isn't it? Or number of favorable outcomes over total outcomes. So this will convert into an equation which represents probability of A, or occurrence of A, plus B minus probability of occurrence of A intersection B is equal to probability of A union B. So you can see that this is then analogy between set theory and probability, exactly representing the same thing, but you can convert number of elements into probability. So this equation is very important for your questions, where you can they can give you different values. Let's say they can give you probability of A, probability of B, and they can give you probability of A union B. and they can ask you for probability of A intersection B. Now, the next thing which is important to understand in probability is when you read question and if they say find the probability of occurrence of this or that. So what's the word there? Or. Okay. If they say or, it means you have to use union. And if they use the word and, it means you have to use intersection. Okay. So you have to read your question carefully. And if you find that they're asking for probability of whatever event A and B, you should use intersection. Okay. So let's take an example. So the example would be, let's say I have two dice. Okay. And you know that from last session I explained you if there are two dice you can simply find out the total number of outcomes by doing 6 square, and that is 36, isn't it? So there are two events. Let's say event A, which represents the occurrence of getting let's say even number. Okay, even number on or even numbers on both dice. Okay, so what is event A? Event A means occurrence of getting even numbers on both dice. So you're rolling two dice, let's say. Obviously you will get two numbers and both of these numbers must be even. And that means that's event A. Event B is, let's say, both number will add up to 6 or let's say 4 maybe. Okay, sum of numbers should be even. Sum of numbers. So you will get one number here, you will get one number here, and if you add both of these numbers, you should get an even number. Okay. And they're asking you what is the probability of occurrence of A and B together. So what word I'm using here? And. It means I need to find out the probability of A intersection B. Okay. So how will you do these questions? So first you need to understand that what is event A, what is event B, and what is their individual probabilities. So what is event A? Even numbers on both dice. Even number on both sides. So you have 6 numbers, and out of 6 numbers you have 3 even numbers, 2, 4, and 6, isn't it? So what are the options? You can have 2, 2, 4, 4, 6, 6. Even number on both dice. You can have 2, 4. So what I'm using is I use this as a doublet. Okay. Then I'm using 2 and 4. So I can write 2, 4 or 4, 2. Okay. Then I can use 4 and 6. So 4, 6 or 6, 4. 4, 6 means on the first dice you got 4 and on the second dice you got 6, and 6, 4 means the other way around. And then I can use 6 and 2. So 6, 2, 2, 6. So as I said, you need to write down the outcomes logically in systematic manner. Otherwise, there is a chance that you will miss one of the outcome, let's say. And if you don't consider that, then you will get wrong answer. So systematic work is important. So I started with double 2, 2, 4, 4, 6, 6. And then I'm writing 2, 4 and 4, 2, isn't it? And then 4, 6, 6, 4, 6, 2, 2, 6. Any other options left? Any other options left here? No, because you consider double, you consider other numbers as well. Okay, so this is the occurrence of event A. So what is the probability of event A then? So how many outcomes you got here? 9. And what's the total outcome? 36. Okay, so that's the answer for probability for A. Similarly, what's the event B? Sum of numbers should be even. Sum of numbers should be even. So 1, 1, 2, 2, 26, 62, 24, 42, isn't it? So sum of the number should be even. So 1 plus 1 is 2. So that's why it's considered as that. 1 comma 3. 1 plus 3 is 4. So I can use 3 comma 1 as well, isn't it? So 1 comma 3. So 1 plus 1 is 2. You can get 2 plus 2, 4. 2 plus 6, 6 comma 2. 2 comma 4. Any other else? 4 comma 4, isn't it? 6 comma 6. So you can use the doublets, isn't it? So you have double here, double here, double here, and double here. And then you can also use 3 comma 3, isn't it? That will give you even number. And you can also use 5 comma 5. So 1 1 2 2 3 3 4 4 5 5 6 6. So they're all giving you even number. And then if you use 1 3, then 3 1 2 6. Any other possibilities? 3 4 is not going to give you. So if you want, you can write down like this. 1 2 is not giving you even number. 2 3, no. 4 3, no. 4 plus 5, no. 6 plus 5, 11, no. So they are not giving you that, isn't it? 6 plus 1, 6 plus 2, which we already considered. 6 plus 3, no. 6 plus 4, we already considered. No, we haven't considered 6 comma 4. So 6 comma 4 and 4 comma 6, isn't it? And I think that's it. 5 comma 3, 5 comma 3, 8, 3 comma 5. Okay, so you can list these outcomes like this. So how many outcomes you have now? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 16 outcomes. So probability of B is 16 over 36. Okay, what about probability of A union B? Union means all together. So all together, obviously you have 16 outcomes, but in the A outcome A, you need to just check if you're not repeating. So 16 outcome. Okay, so what is repeating? 4 4 is repeating, so I'm just cancelling like that. 4 comma 6 is already there, isn't it? 6 comma 6 is already there. 6 comma 2 is already there. 4 comma 2 is already there. 2 4 is there. 2 2 is there. 6 4 is there, and 2 comma 6 is there. Okay, so it's all there. So the total is obviously 16 over 36 as well. Okay, so based on that, you can find out now intersection. So 9 over 36, that's for probability of A. And then this is for B. Intersection, let's say we don't know. Sorry, intersection we don't know. And union is 16 over 36. Obviously this and this gone. So intersection is equal to 9 over 36. Okay. So I just explain you how to write down the outcomes and how to use this equation. Obviously this is just I made this question. So this is how you need to work out. Okay. Now the next thing is conditional probability. So what is conditional probability? Conditional probability, as you can see the name. So if you have a pack of cards, how many cards you have? Total 52. Okay, I want to write down the probability of getting, let's say, ace. So 4 over 52, isn't it? That's the probability of getting ace if we want one card out of 52. But now let's say I kept this card here and I'm not disclosing this. Okay, the first card. Now how many cards left? 51. And I want to find out the probability of ace again. Anybody can guess what is the probability of getting ace now in the second attempt? Any idea? What would be the probability of getting A's in the second attempt?
Is it 3/51?
3/51. Okay, let me see. Sorry. Okay, so Anastasia said that it's 3/51. Okay, no, that's not correct. And the reason for that is we don't know what was this card. Did we? So it depends. The occurrence of this event now will depend on the result of the previous event, isn't it? I didn't said that the last card was ace, and this is called conditional probability. So the occurrence of second event is actually depending on the occurrence of the first event. So there are two possibilities. If the first card was ace, then you are right. Answer is 3/51 because obviously 3 aces are left there and total cards are now 51. If the first card was not ace, then the probability for the second event would be 4/51. Okay, so this is the concept of conditional probability. Now, question is how you will use that information you given in the question to get the answer. So the formula for conditional probability is A straight line B equals to probability of A intersection B over probability of B. Now you have to be careful here. First of all, how to read this? This is called probability of A depending on probability of B. Okay, so that's the conditional probability. So the letter which you're writing in the second place is basically your, let's say, first event. Okay, and whatever you write here, it should go here. Okay, so it doesn't matter what you call that A, B, but if you write B here, you should write probability of B in the denominator. Okay, so this is the formula for conditional probability. We'll do questions based on that, but I just wanted to explain you first what is the concept. Okay, now within that concept, we can talk about independent events. Independent events means, as the name says, independent. So the occurrence of second event is not depending on the first event, which means if I take the same example of 52 cards, I want to write down the probability of getting ace, you will say 4/52, and then I am keeping this card back to the the pack of card. Okay, so which is called without or with replacement, sorry. Which means that you still have 52 cards now and you are finding the probability of, let's say, whatever event, doesn't matter. Let's say I want to find out probability of spade. So you will say 13/52. So the total number of cards is same, and the occurrence of this event is not depending on the first event because you are keeping that card back to the the pack of card. So these events are called independent events, and in that case, the probability A's line B will be equal to A probability of A, because it's not now the conditional probability. Okay, it's not the conditional probability. So it means that this formula will turn into A intersection B is equal to P of A multiplied by P of B. And this is called multiplication rule as well. Multiplication rule. So multiplication rule actually comes from the conditional probability with a special case of independent events. So the tricky thing is you have to read the question carefully. Once you read the question carefully, then only you can decide whether they're talking about independent events. If they talk about independent events, you can use this formula. And as I said earlier, in case of probability, if you use the word and, you need to get probability of A intersection B. And means intersection, and or means union. Okay, or means union. So A union B is equal to P of A plus P of B minus P of A intersection B. This is one formula, which is also called addition rule in probability, and the previous one is called multiplication rule in probability. Okay, so this is the concept of addition rule, multiplication rule, conditional probability uh, in this case. Now on the left side, I have a question here, which we can try that. Okay, so this is 2019 question number 6, and you can see that they already bold this word independent. So two independent events F and S are represented in the Venn diagram. So Venn diagram is already given in the question, so I can use that. This is F, this is S, F, S, this is 1 over 4, this is 1 over 5, this is X, and this is Y. Okay. So now don't get confused between A vertical line B or A slash B. These are two different things. Can someone explain me what is this A slash B means? This one I already explained you. This is conditional probability. What do you mean by A given that B occurred? No. Recall your concept of set theory. What is A slash B means? In simple words, A slash B means A but not B. A but not B. Or you can also say A minus B. That's the most simple way of doing that. How to represent this in the Venn diagram? This is A, this is B. If I want to shade A slash B, it's this. It's A without B. Okay, so there is a big difference between if you put a vertical line or you put this slash button symbol A slash B. So in set theory, A slash B means A minus B, and it's the same concept here, and that's why if you see the question there, so I'm writing question again just to separate this. So they give you P of or probability of F slash S. So this is not conditional priority. Otherwise you will say, okay, we just talk about conditional priority and they are talking about independent events in the question. Okay, so you have to read the question carefully. Give me a second, please. Okay, sorry, just back. Okay, so that's the idea behind conditional priority. So this is not a conditional priority. This is telling you F slash S. And you can see in the Venn diagram, it's 1 over 4. So it represents F without S. They also give you F intersection S in the Venn diagram as well, 1 over 5. And they are also writing S slash F as X, which means S without F. Okay. And they also give you F union S complement. Now, what do you mean by complement? So this complement or dash means it's outside F union S. So you can see that Y is outside the circles. Okay. So complement means those elements which are not in F union S. Okay. So that is all given. What they want is the value of X and they want value of Y. So how will you find out the value of X and value of Y? So as I said, so they both events are independent events. Both events are independent events. So independent events means I can say F intersection S equals to probability of S multiplied by probability of S. Agree? So let us substitute the values. Intersection is 1 over 5 and probability of F. What is the probability of F? Probability of F means 1 over 4 plus 1 over 5. Okay. You can see that in the Venn diagram. The total probability for F, event F, is 1 over 4 plus 1 over 5. Now, P of S. What is P of S? We don't know. Let's say. So let us find out this P probability of S. So probability of S, so this is 1 over 5 and this will give you 9 over 20 if you find the LCM. So the probability of S will give you 4 over 9. But we are not interested in probability of S, we are interested in X value. So according to the Venn diagram, what is X? X should be probability of S minus 1 over 5. That's the remaining part. And 4 over 9 minus 1 over 5 will give you 5 for the 20, 20 minus 1, 20 minus 9 is 11. So 11 over 45. So this is the value of X. Okay, so we got X. Now, how will you get Y? Anybody can guess? How will you get the value of Y now? Very good. 1 minus everything. So everything means the total probability should be 1, isn't it? So total means 1 over 4, 1 over 5, x plus y equals to 1. So 1 over 4 plus 1 over 5 plus x. X is 11 over 45 plus y equals to 1. And then you just have to solve this. Okay. So y equals to 1 minus everything, and then you can use calculator. Okay, but this will give you the value of y. So you need to understand the concept. Doesn't matter how many questions you do. If you do 10 questions properly and understand what's happening in the question, you can do any question. Okay. Okay. We'll come to this question later. Now the next topic which I would like to explain um, is the Bernoulli trial. So there was a question here in your. This question we already did, I think, last time. And we'll come to this expected value later. Okay, this is another question. We can try that. This is 2016. Question number 5. And I will do part B. Part B first. So you have the diagram there. This is A, this is B, this is X, this is 0.1, and this is 0.3. In terms of writing it, they give you A probability of A intersection B 0.1. They give you probability of B slash A. So it's not a conditional probability. 0.3 probability of A slash B, or A minus B, which is X. Okay. You need to find the probability of A. So what is the probability of A? And they said that find the value of X. First, you need to write down probability of A in terms of X. So let's focus on probability of A. So what is probability of A? Probability of A is X plus 0.1. Okay. You can clearly see in the diagram. And find the value of X for which the events A and B are independent. A and B are independent events. Okay. So independent event means A intersection B equal to probability of A times probability of B, isn't it? A intersection B is given in the question 0.1. Probability of A is X plus 0.1. And what is probability of B? It's 0.1 plus 0.3, isn't it? That's it. You just have to solve this. So X plus 0.1, that's 0.4. So X plus 0.1 equals to 0.1 over 0.4. Okay, so what it will give you? 1 over 4. So X is equal to 1 over 4 minus 0.1. 0.1 is, okay, let's keep at 0.1. So 1 over 4 means 0.25 minus 0.1. 0.25 minus this is 0.15. So that's the value of X. Okay, so this was another example in your exam paper, so that's why I did this. So let's move on to This is another similar question, but I think you can try this later now. Yes, this question. This is very important based on Bernoulli trial. A lot of students struggle with this as well. So first, let's understand what is Bernoulli trial. So what do you mean by Bernoulli trials? And when you will understand that, okay, this question is about Bernoulli trial. Well, sometimes they won't tell you it's Bernoulli trial, so they will just say that. So what is Bernoulli trials? Any idea? You probably did this chapter in school, isn't it? Most of you. So what is Bernoulli trial? No idea. So what it says here, trials. What do you mean by trials? Only win or lose situation. Well, not really. Um, because if I play a game with, let's say, with someone, and I say, okay, we have 52 cards. You pick one card, I pick one card, okay, and we can decide, okay, you are the winner if you get, let's say, a black card. I'm the winner if I get red card, isn't it? So, not exactly. Trials means something which you are trying again and again, isn't it? So if I have a coin and I'm flipping this coin, let's say 100 times. So it's the same coin. I flipped one time. I got either head or tail. Second time, third time, fourth time, and 100 times. So I am, first of all, Bernoulli trial means the main condition is you are repeating the same experiment again and again. Okay, it's an experiment or a trial. So you are doing same experiment again and again. And that is the application of Bernoulli trial. Now, why we need it? Because it will help you to find out the probability, okay, using this formula. So probability is given by NCR P to the power R Q to the power N minus R. Small p and small q I'm using here. Small p means probability of success. Q is probability of failure. And what is R? And what is N? N means number of trials. So if you're doing the same experiment 1000 times, so N is 1000. And what is R? Anybody know what is R here? What R represents? What it represents? See, that's the thing. I'm not asking you any complicated question. These are the questions you should ask yourself whenever or whatever topic you study in maths or in physics, let's say. Okay, chemistry and biology is still okay, it's more theoretical, but R is number of times you get success, or number of times you want to be a successful, okay, in your trials. Yes, number of successful trials, that's correct. And Anastasia said. So P means the probability of success, Q means probability of failure, N means number of trials, or is number of times you get success. So if you have a question where you are doing the same trial again and again, it's a Bernoulli trial. And how to get the probability? You can get the probability using this. NCR you can calculate using your calculator, isn't it? It's given in your calculator. But important part is n is number of trials and r is the number of times you get success, which will be given in your question. Okay. Same for P and Q as well. Now, one more important thing about this is probability of success should be equal to, or the probability of failure should be equal to 1. So either uh, it will be favorable to your event, or it will be unfavorable to your event. Okay, success plus. So there is no probability of the event which is not belonging to success or failure. Okay, so that's why I give you this example, that if you considered any two events, isn't it? So in this example anyways, so red, you can get either red or black. You can't get, let's say, a green card, isn't it? So that is one type of experiment. But if I say there are two experiments, okay, I am the winner if I get, let's say, ace, and the other person is the winner if they get, let's say, jack. Okay, but there is a probability that you will get something else, isn't it? So nobody will be the winner in that case. So that kind of experiment is not according to the Bernoulli trial. Okay, so that's why you need to understand this. So let's try this question and you will get a better understanding now. 2012 question number 4. A certain basketball player scores 60% of the free throw shots she attempts. 60% of the free throw shots she attempts. During a particular game, she gets 6 free throws. So how many? 1, 2, 3, 4, 5, 6. Total 6. So what is n? 6 here. Number 2. What is the probability of success here, which is P? Anybody? First of all, it is Bernoulli trials because you are attempting, or you're doing the same experiment again and again. You got 6 throws or shots. And what is the probability of success here? Any answer? No answer? No idea. Guess something. It doesn't matter. It's right or wrong. Okay, the hint is, okay, Holly said 3.6. How you got 3.6? First of all, the probability cannot be greater than 1. That's impossible, isn't it? Probability is always between 0 to 1. That's the scale. But how you got 3.6? Oh, 0.6. Yes. 0.6 is, was it a typo, Holly? Okay, so you thought about 3.6 earlier. Okay, 0.6. How we got 0.6? Because they said a player scores 60% of the free throw. Scores means it's success, isn't it? So 60%. So I told you that probability you can convert into percentage if you multiply by 100, isn't it? So if it is given in percentage, which is 60%, you can work backwards, which means you can write down in decimal form, which is 0.6. So probability of success is 0.6. So they can give you probability in different ways, like in percentage, or they can say score. You know, some players scored this and that. In that's the probability. And if you know that the probability of success is 0.6, so the probability of failure should be 0.4, isn't it? 1 minus 0.6 is 0.4. So we got Q, we got P, we got N, which is 6. Now let's read the question. First question. What assumption must be made in order to regard this as a sequence of Bernoulli trials. I already explained you what is the main assumption that it should repeat. The same experiment should repeat. Okay, so that's just a question. Now, part B, based on such assumption, find correct to 3 decimals places the probability that she score she scores on exactly 4 of the 6 shots. 4 of the 6 shots. So what they want is they want success 4 times out of 6 attempts. So let's use the formula. The probability is equal to 6C4. P is 0.6 to the power R, which is 4, and Q is 0.4 to the power N minus R, which means 6 minus 4, that is 2. Okay, that's the answer. They said exactly 4 times. Okay, that's another word which you need to be careful. So that's the answer for this part. Let's read the next part. She scores for the second time on the 5th shot. She scores for the second time on the 5th shot. 1, 2, 3, 4, 5, 6. Total 6 shots are there. Okay, you got 6 shots, but they said she scores for the second time on the 5th shot. So you should have success here. Number one. That should be the second success. Now, there are multiple possibilities here. Multiple possibilities is she may get success in the first attempt. Okay, fail, 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 isn't it? She may get fail in the first attempt, success here, fail, fail, and then success, isn't it? So that's also second time she will get success on the 5th attempt. It may be fail, fail, success, fail, success. It may be fail, 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 success, success, like that, isn't it? So that's why I said in the previous question they said exactly 4 shots. So you cannot say, you know, for whether it's a first 4 or last 4 or whatever. So that was fine. Okay, but in this question you have to be careful. So she scores for the second time on the 5th shot. So first what you need to do is find out the probability. Okay, so what will happen to the last shot then? Last shot, so let's take an example. This is the 5th shot, which is a success. Let's say she got success here, and the last shot can be a success or failure, because she scores for the second time on the 5th shot. They did not say anything else. They did not say that the total success should be 3 or 2 maybe. First, let's take an example of this. She got 2 success out of 6. So what's the probability? 6e2, 0.6 to the power 2, and 0.4 to the power 6 minus 2, 4. So this is the probability for 2 success. But we want second success on the 5th attempt. So how will you consider that? How will you consider that? Any idea? So if I'm writing this a probability like this, I'm just saying that she got 2 success. Okay, but we want success on the 5th attempt. So how will you consider that? Any idea?
Would the R be tree then?
3, sorry, what's 3?
R?
R would be 3. Okay. So what 3 indicating? So 3 means 3 success. So you're saying the other possibility is 3 success. But I'm saying that if you use this formula, okay, and you say that you got 2 success, but that formula is not telling you that the fifth attempt is a success, isn't it? So what we will do first is we don't care about let's say the last one. Okay, the problem is not the last one. Problem is the first 4 attempt. Okay, these 4 attempt, and in these 4 attempt we should have only one success. That then only you will get a possibility of second success in the 5th attempt, isn't it? So what we will do, instead of using this, you should say 4c1.6 to the power 1 and zero point 0.4 to the power 3. That is giving you the probability of one success out of 4 attempt, first 4 attempt, isn't it? Multiply by, that's the probability of one success, but you want second success. And what is the probability of second success? 0.6. Okay, so exactly one success in the first 4 throws, followed by success on the 5th attempt. So that's your 5th attempt. Okay, that's your 5th attempt, and that's your first success in the first 4 throws. So this is how you need to work out. Okay, so that is the question related to Bernoulli's theorem. Okay, so let's try maybe this one, 2011. There are 16 girls, 8 boys in a class, and half of these 24. Did we do this question last time? Did we attempted this question already? Last time? So the probability that a randomly selected girls, yeah, I think we did this already. Okay, so that's fine then. Yeah, so we don't have much time, so I'll maybe do this question quickly. So this is 2010 paper. Question 1. So 2 events A and B are given, and you can see that the probability of A is 0.2. Probability of A intersection B is given 0.15, and probability of A complement intersection B is 0.6. Okay, you just have to complete the diagram first. So draw a rectangle, 2 circles. Let's say this is A, this is B. So A intersection B is 0.15, so that's there. Probability of A is 0.2. Okay, so probability of A is 0.2 means what? Is the total probability of A. So if it is a total probability of A, what should be the remaining value here? 0.05. And how will you find out? So what's this? A complement intersection with B. So A complement means, so I'll just shade this for your reference. So A complement means not in A. So that's A complement. So that's all A complement. Now intersection with B. So what is that intersection with B? So this is the intersection with B. Okay. So this is what representing 0.6. Okay. So this is 0.6. Now I need to find out if something is outside as well. So 0.05 plus 0.15 plus 0.6. 1 minus. Okay. So it will give you 0.15 and 0.05 is 0.2, 0.6. So it will give you 0.2. So this is 0.2. Now in some questions you may not get anything, but you have to check that the total, if the total is 1 or not inside the A and B. Find the probability that neither A nor B happens. So which we already got here. So this actually represents neither A nor B. So that's the answer for the part B. Okay. Now they're talking about conditional probability. So you can see that it's a vertical line. And what's the formula for conditional probability? A intersection B over probability of B. So what is A intersection B? 0.15. And what is probability of B? Probability of B is 0.6 plus 0.15. 0.6 plus 0.15. So this will give you the conditional probability. State whether A and B are independent events. So how will you prove that they are independent events? So for the independent events, A intersection B is equal to probability of A multiplied by probability of B. So probability of A is 0.2 and probability of B is 0.75. So you need to check what's the answer for this, and this answer should match with this. If they are matching, it means they are independent. If they are not matching, then you can say it's not. Okay. Okay, so that's the idea behind conditional probability and Bernoulli trials, Venn diagrams, multiplication rule, addition rule. So I would say you need to practice this. And the only part left is the expected value questions. And I think some questions, yeah, so that's the expected value questions, so which we need to do. And then some questions based on that. Now this is not bad, but we'll attempt this question as well. So that's the only thing left in probability. Okay, so any questions? So hopefully we will finish this next week, and we'll also start statistics. If you want to start statistics. Okay. Any questions? Or you're okay? Okay, so I'll meet you guys Tuesday as normal, 7 o'clock. Okay. Okay, take care. Thank you. Bye.